Hello guys, let me walk through with the lab called building circuit with a light bulb. So this is in module 3. You can read the purpose of the lab is to construct serial and parallel circuits and measure the voltage and current through each type of this circuit. So you can read the background information and vocabulary and background. Yeah, then I will start from the procedure here. So let's go to Beyond Labs webpage and click open here, then wait for a few seconds, then we'll get to see the page for physics. So you can either click circuit here or the worksheets under electricity and magnetic. So number 3 is building circuits with light bulbs. So click that and we'll see the workstation. So if you're not familiar with this one, you can practice using this circuit diagram lab. Okay. So now I will start this lab with the first step. The procedure says we'll get this building circuit with a light bulb. Yeah, I did this, and number 2 shows what kind of the materials showing here. We need this light bulb, the DC battery. I think that's it. That's 2. Yeah, put them either in the serial connection or parallel connection, and record this the result. So move to step 3. There are several sub-steps. So step 3 is that you will first build a single DC light bulb serial current the circuit on the pad of paper, which is this one, and you will build it in phases and examine each phase as you go along. So the first phase 1 light bulb. So please play this light bulb, which is this one over here on the pad paper. You can move around. Then add this functional generator symbol. Connect where between function generator and the bulb. So the circuit should be complete now. So we can bring this one here. That's the CD, that's DC battery. So connect one end with the right and another end to the negative parts. So now we can increase the voltage up to 12. So it's a significant, it's a maximum one. You can see the light on the light bulb. So that's the the first this step. In phase 1, we get connected and increase the voltage up to the maximum 12 volts. So it's not 15 volts, it's 12. So I make some make this modification here. So once we finish this, we can save it. Then if you open the MacBook, so the image is saved like this. So close it. We'll move to the second phase. If you turn to page 2 in the lab description, at the top is phase 2, 2 LED bulb in this series. So we can click over here, reset lab. So remove one, add one on the pad paper, the pad of paper, then put this, the source DC battery at the bottom and connect them. So connect the positive end and negative end, then two balls. So now can see the light. It's on, not as bright as when we have just one bulb. So that's the phase 2 LED bulb in series. Okay, then we can record this just by saving and finish the second phase. Then we reset lab, move to phase 2, 3 light bulb in series. So we add 3 of them. 1, 2, 3, and this 2. So connect them. You can connect them later or now. In theory, then the positive pole of the battery and the negative one. So now you will see this, the light. Let me move this over here. It seems, let me redo this because the position is not very good. So 2 and 3. Then we connected those and bring the DC battery here. No. And now you can see that there's no light from the bulb. So then you can record this observation in the table for this series circuit date table. So if we remove one, then you will see the difference. So now I remove, no, let me record this first, then put 1 back and connect. So now you can see the weak brightness here. So then finish the description in this table and move on to the next part. So that's let me save this in the lab book. So the next one, number 4, step 4, you will build a simple parallel DC circuit, and you will build it in phases and examine each phase as you go along. So let's reset the lab. The phase 1, 2 light bulb in parallel, and so that's 1 and 2. Then we bring the source here, the DC battery, and connect positive side and negative side. So you will see the brightness of those 2 bulbs are greater than greater than the ones in series. So let's save this result, and you can record this in the table, in the following table. So 2 and 3. Then in phase 2, 3 LED bulbs in parallel. So we can add 1 more. Let me try. Can I do this? 1 more. Yes. So they are in the same intensity of brightness. So that's this part. They can record the observation and move to yes. So if I remove 1, still the same one. That's the result. So you can put those results in parallel circuit data table, and after that you are able to answer questions from 1 to 5. And that's it for this lab. Thank you for watching. Bye-bye.